In this video, we will discuss the normal distribution. An interpretation of the standard deviation is in its relationship to the normal distribution, which is an arrangement of a data set in which most of the data values cluster around the mean and the rest taper off symmetrically toward the ends. The graph representing a normal distribution is a bell-shaped curve. Here, S represents one standard deviation. So we have one standard deviation between each of these lines here. And we can see that in these two lines closest to the mean, in these two regions closest to the mean, we have about 34.13% of all of the data values. In this region's second closest to the mean, we've got 13.959% of the data values. And in the region's third closest to the mean, we've got 2.15% of data values. Beyond that, we only have 0.13% of data values. The normal distribution curve is symmetrical around the mean. Half of the data fall below to the left of the mean, and half fall above to the right of the mean. 68.26% of the data falls within one standard deviation of the mean, 95.44% within two standard deviations, and 99.74% within three standard deviations. To solve applied problems involving the mean, standard deviation, and a normal distribution of a population, first, locate the mean and the desired values on the normal curve. Value minus population mean divided by population standard deviation is equal to the number of standard deviations above or below the mean. Second, highlight the desired regions of the normal curve based on the conditions of the problem. And third, add the percents associated with the highlighted regions in step 2. For example, an AutoZone Duralast Gold car battery has a population mean life of 46 months with a population standard deviation of 4 months. In an order of 100 batteries, how many would you expect to last less than 54 months? First, calculate the number of standard deviations from the mean for 54. That's the value minus the mean over the standard deviation. It's 54 minus 46 over 4, which is 8/4 or 2 standard deviations above the mean. Here is our standard deviation graph. Here's one standard deviation and two standard deviations. 50%, this whole half here, plus 34.15% plus 13.59% is 97.72%. So 97.72% of the batteries should last less than 54 months.